First of all, the BeagleBone Black is similar to the Raspberry Pi, but the packages are a bit different. In my case, I have prepared the BeagleBone Black to be connected via SSH, just like the Raspberry Pi. I am now connecting. I'll definitely give it a try. Firstly, I'll update the package manager list and check for updates. I have updated the list. Next, I will install the necessary packages, sudo apt-get install USB and to automatically agree to all the prompts from liboost and cmake, you should select Y for each prompt that appears. This will ensure that the installation process continues without any interruptions, as it will confirm all the necessary steps required by these tools. The installation is now complete, and next, I will download the necessary and important source code files. The download will begin. It's completed, and now I will try to build it. If you enter the Pixy script, it will move here. And then if you look at the files, there is a shell script for building the USB-related libraries. Please execute this shell script. The build is now complete. To provide more details, the Pixy script is essential for the movement, and the shell script is crucial for building the necessary USB-related libraries. To elaborate on the process, ensure you follow each step carefully. This will help to explain the steps involved and ensure clarity and understanding. Next, you need to install the built library. To complete the installation process, please enter the command sudo install in your terminal. Yes, the installation is now complete. Now let's build the example. We will build HelloPixie from the examples, so please simply enter this command. The build is now complete. Now let's just run the example. For example now. After moving to the top folder in your directory structure, you will notice the presence of the build folder, which contains all the necessary files for the project. In the build directory, I will now run HelloPixie right here, which is actually called HelloPixie. So, as it runs, you can see the version displayed earlier, and now the data is being shown, but it is not being recognized. In this state, I will place an object in front. I have now connected the Pixy to the BeagleBone Black via USB, and in this state, when I place an object, I can see the data being displayed on the terminal like this. I have now exited the program. Let's take a look at the HelloPixie source code. Move up from CD, and here you will see the source folder. Type cd src, then cd host, and you will find HelloPixie. CD HelloPixie, which is a project that provides detailed and comprehensive C++ source code for developers to explore, understand, and learn from. You can see the CPP source code here. When you run it, this is what actually appears. So let's take a look. Now, there are block information related aspects that can be received as an array, and just like with the Raspberry Pi or Arduino, we add the Pixy header here and call the Pixy library. Well, up to this point, it seems similar to the Raspberry Pi. This text discusses setting up interrupts to configure termination, displaying the version during execution, and initializing the Pixy library while checking for initialization success. Depending on whether the initialization was successful, the program may terminate or continue. It also mentions requesting the firmware version, similar to what was done with the Raspberry Pi previously. There are macro constants related to conditional statements. and since the value is currently 0, this part does not execute. However, for those who want to debug in detail, changing it to if 1 and building it will display more detailed information. The text then moves on to recognizing blocks and mentions that the rumble flag is similar to what was seen with the Raspberry Pi last time. The rumble flag operates in an infinite loop, but unlike the Raspberry Pi, it checks for newly recognized blocks with PC blocks are new. If there are new blocks, the while loop continues. If not, it remains stuck in the while loop. Now, if we move on, we can see that the block buffer size we looked at earlier is currently set to 25. You receive information related to a maximum of 25 blocks as an array, and then insert it into the array variable that was previously labeled as blocks at the top. In the case of blocks copied, it determines how many recognized blocks there are using gap blocks, which are essential for the process. If the result is -1, it indicates an error. Otherwise, it proceeds to loop through each block and display the block information in detail. At the end, when the program is terminated by pressing Ctrl+C, it is set to close the PC. This time, we connected the Pixy2 to the BeagleBone Black and controlled it. In the next session, I will explain how to control the Pixy2 using various interfaces as I mentioned last time. Then, I will see you in the next session.